Okay, so today I'm going to talk about transformations and just show some examples and explain it first of all. So I'm going to talk about three main types of transformations. First of all, there is translations, there is reflections, and there are stretches. And for each of them, there's a vertical and horizontal. So there's horizontal stretch, horizontal reflection, and horizontal translation, and vertical translation. For translations, there's vertical and horizontal translations. For vertical translations, you add the K to the Y. And for horizontal translations, you add the H to the X. And then there's reflections. There's vertical reflections and horizontal reflections. You add a negative to the Y for vertical reflection, and you add a negative to the X for horizontal reflection. And lastly, there are stretches. So there's vertical and horizontal stretches. And for vertical stretches, you multiply the A to the Y. And for horizontal stretches, you multiply the reciprocal of B to the X. Before you even start graphing functions, you have to kind of understand the formula of a function and where all the transformations go and how to figure it out. So in this case, A is represented by the vertical reflection or the vertical stretch. F is the type of graph. B is the horizontal reflection or the horizontal stretch. H is the horizontal translation, and K is the vertical translation. And B, or the horizontal stretch, is by the reciprocal, so if it's 1 over 2, it's really 2, and if it's 2, it's really 1 over 2. In order to get an accurate graph, there's an order you have to apply the transformations. First is stretches, then reflections, and then translations. There's also the inverse of a function, which is basically switching the x and y in the function, and I'll show you how that works. So like here, you switch the x and the y, and you can solve using that way. Then you can also swap like the mapping points, like I show you here. This is the first example. It's a quadratic equation, and I'm listing all the different transformations in the function. And first of all, I'm going to graph the basic quadratic function. And now I'm going to highlight that just to show the different steps. So now that we've done that, we have to start applying the transformations. So the first one we're going to do is the stretches. So the vertical stretch by 2 and horizontal stretch by 1 over 2. So as you can see, I'm graphing that on there. And now I'm highlighting it to show the different steps. And the second transformation we're going to be doing is reflections, and there's only a vertical reflection, so that just reflects over the x-axis. And now I'm highlighting that to show that step. And the last step is the translations, and there is a vertical translation by -4 and a horizontal translation by -3, and I'm just graphing that to show you there. And now I'm highlighting it to show that is the final step, and that is the function graphed. And now I'm verifying this function on my graphing calculator just to show that I did it correctly. And there it is, it's correct. And now on to example 2, which is an inverse of a function. So the first step I'm doing is I'm just replacing the x with the y, and then I'm rearranging for that and moving everything around. And I get y equals 2x plus 12. Now I'm going to graph the original function, not the inverse, the original one, and I'm using the rise over run method, and then so I'm finding the y-intercept and then doing the rise over run. Now I'm just drawing the line on the graph to show my original function. And now I'm going to graph the inverse function. And I'm highlighting to show the difference. So here I find the y-intercept, and then I'm doing the rise over run method. And now I'm just graphing the line. And highlighting it to show the difference between the inverse and the non-inverse. And I'm doing the domain and range for both functions, the inverse and the original function. And the domain and range end up being the same thing. The domain is XL reals and the range is YL reals for both. And now I'm verifying my inverse graph by using a data table to write down the original function's plotting points, and then I'm going to switch them and double check them to make sure that I did the inverse graph correct. As you can see, I did the inverse and I swapped the mapping points, the x and y values, and now I'm double checking them to see if my graph is correct. And as you can see, it's correct. As well, to verify, I'm using my graphing calculator to check my graph of the inverse function. And as you can see, it's the same. Thank you for watching my summary and letting me show you some examples of transformations.